So, as you know, your exam is Thursday, not today. So if you're online, that's kind of a relief. So, has anyone started studying? Okay, you may want to. So I put up a little review topics thing that I basically took what I put on the final exam last semester, and I just cut it down to what'll be on exam 1. So before we begin, are there any questions or anything specific that you want me to cover today? So your chapter 4 homework, actually, I pushed the due date back 5 days. So, I don't know if it's 5 days or what. It's due on Sunday now. So that way you don't have to worry about it before the exam. Okay. So I guess let's start from the beginning, what we talked about. So chapter 1 was all about descriptive versus inferential statistics. So you probably should know the definition of what descriptive and inferential is. So I'll write that up here. There. Where'd the marker go? We'll just use this one. There it is. So descriptive statistics consisted of the summarization, organization, and presentation of data. So then what was inferential? There really wasn't a definition for it. So inferential, I'll say it this way. Using past information to make predictions, we'll say that. So, like I said, chapters 1 through, I think it's 1 through 6 are about descriptive, 7 through 10 are about inferential. Is everyone okay? Good. Okay. So then we moved on to the 4 levels of measurement that we classified stuff based on. So nominal, ordinal, interval, and ratio. So nominal, anyone remember what that was? So it was categorical data with what? No natural ordering. So anyone give me some examples? So one I put on the exam last semester was, I think it was candy flavor or something like that, or candy color. So I'm pretty sure that came from your homework. Another one is dog breeds, animal breeds. So then we talked about ordinal. What was that? It was basically nominal, but there was order. Nominal, but there was a natural, or to say there was a ordering. So on the practice exam that I posted, there should be a couple of them. I can't remember which one it's on. It's on the fall one or the other one. So there's a couple ones that'll go over those 4 different ones. So the last 2 are kind of iffy, in interval and ratio. So the difference between the two is ratio, you can make comparisons. So that's kind of the difference there. So then we talked about sampling techniques. So you need to know to which techniques do we apply some different way of sampling. So for, what was the first one? Random. What made it random? So a random sample, so let's just say RS, is when each member of the population of interest has a equal chance of being selected. Can you read descriptive? Oh, Bailey, it's the summarization, organization, and presentation of data. So then we moved on to systematic. So what was that defined by? So systematic was we sample every K member of the population of interest. And then stratified, what was that? So stratified, you divide the population into subgroups, which are also known as stratum. And random samples are taken from each group or each subgroup. So you should know how to tell based on a scenario which sampling technique was used. So then we talked about observational and experimental studies. So what was observational? It's in the word. You merely observe. So observational. Merely observe to see how some characteristic or variable changes over time. So you're just observing something. Hint, the word observational. So then experimental. So in that one, we actually have treatments assigned. Treatments assigned to see how they affect the response variable. So then within an experimental study, we had independent and dependent variables. So which one was changed or could be changed or manipulated? So remember the acronym ReadyMix. So R stands for response, D for dependent, Y for the y-axis, M for manipulative, I for independent, and X for the x-axis. So the independent variable is the one that is being manipulated or changed by the researcher, and the dependent variable is the response that we're measuring. So know how to differentiate between the two and how to identify it if I give you a graph. That should be kind of obvious. X variable, independent, Y dependent. So then we talked about continuous versus discrete. So what was the difference? So a continuous variable can take on an infinite number of values between any two values. Continuous variable can, we'll just say, assume an infinite number of values. Sorry if my handwriting gets slanted. So then we said discrete was what? You can count the number of values. So discrete can be counted. Or the other word that we used was measured. So you should know how to identify which one is which. So if I put on there, what type of variable is the number of students in this class? What would that be? Discrete, because I can count the number of you in here. What about your grade to the nearest percent? Yeah, discrete. So we can take on values 0 to 100. So that was all for chapter 1. So then chapter 2, this is when we talked about graphs and stuff. So you should know how to draw some graphs. So the basic ones that we talked about that I expect you to know how to do. So if you look on the fall 2020 exam that I posted on Canvas, so know how to draw a histogram bar chart. Or what was the other one? Time series graph. So what was the difference between a histogram and a bar chart? Anyone remember? So histogram dealt with numerical data, bar chart dealt with categorical. So we were basing something off categories, and then the height of the bars were based on the number of people that fell into that category. So given any of these, you should be able to determine what is the frequency of that if I give a height on the bar. So know how to determine frequency. So say, for instance, if I give you a graph, or not a graph, if I give you the actual table and a graph, you should be able to tell between which two values does most of the data lie. So now to determine the frequency, the relative frequency, so cumulative, so whenever we talked about something in chapter 4, how could the relative frequency be interpreted? Finding the probability. So say, for instance, I gave you a graph and I said, I want you to find the probability that this random variable lies between these two values. So then if those two values only take up one bar, it would be the height of that bar divided by the total frequency. If it was between 2 or 3 of them, you would take the frequency of each of those, add them up, and divide by the total number. So you should know how to do that and how to determine which is what, or how to determine what you need to look at. So finding the range, you know, that's pretty easy. The minimum, not the minimum, the maximum minus the minimum. I was thinking of the mid-range. So how do you find the class midpoint? Class midpoint is found by the minimum of the class plus the maximum divided by 2, or you can say the lower limit plus the upper limit and divide that by 2. So, and then we talked about how to find the class boundaries. So that was pretty simple. So if you had a whole number, say for instance, we have 101 to 105. What are the class boundaries for that? So to do that, since it's a whole number, you take off a half from the bottom. So it'd be 100.5, and you add half to the top one, be 105.5. So then from there, you should also be able to tell what the class width is. So CW is the class width. So if you do the subtraction of this upper limit minus the lower limit, that is 105 minus 101, which is 4. And if you do 105.5 minus 100.5, the difference is 5. Which one do you think it is? Yeah, it's 5. Because whenever you create a frequency distribution, you take this lower limit and then you add the class width to get the next lower limit, and you take off 1 to get the upper limit of the preceding class. So whenever I take this right here and subtract it, I'm missing 1 from the class width. So calculating the class width, does anyone remember how to do that? That's using the range and the number of classes. So the class width was found by the range divided by the number of classes I tell you. So say, for example, the range was 9 and the number of classes is 5, then the class width would be 9. Oh, that was ugly. 9 divided by 5, which is what? Yeah, 1.8. And if the class width ends up being a decimal, what do? Round up, so it'd be 2. So we already talked about how to find the relative and the cumulative frequency. So the relative frequency was the frequency of some class divided by the total frequency. And the cumulative frequency was the frequency accumulated up to some upper class limit. So then we talked about 3 common distribution types that I said you should know. So there was symmetric, left skewed, and right skewed, and know how it affects the mean, the median, and the mode, depending on what skew you have. So if I have a left skewed distribution, so that would look something like this. Okay, you should know how to determine where the mean, the median, and the mode should be. So remember that the mean is affected by extremely high or extremely low values. So if it's left skewed, which of the 2 is affecting it? So we have most of the data right here at this upper end, but there is not much on this lower end here. So what's affecting it in that case is the extremely low data values. So what is it doing to the mean? It is pulling it down towards this tail. So the mean should be here. The median, which is the midpoint, or the 50th percentile, should be roughly somewhere. So we have probably most of it will be right around here. And then the mode is obviously at the peak. So then based on this graphic interpretation, you should be able to make something like this that says the mean is less than the median is less than the mode. So what would it be for a right skewed? Yeah, you just flip the graph. So that would be the mode is greater than the mode is less than the median is less than the mean. And then if it's symmetric, what is the relationship between all of those? Yeah, they're all the same. Yeah, go ahead. So there actually is a question on the practice exam that actually deals with it. It's number 12. If a distribution is skewed to the right, which of the following most likely will be true? And it gives you 4 options. One of the options is correct. You have to be able to determine which one. So Then chapter 3, we talked about the measures of central tendency and the measures of variation. So the measures of central tendency we talked about were the mean, the median, and the mode, and that's the three main ones. So the mean, the median, and the mode. So those are the three main measures of central tendency we talked about. So you should know what mu represents. Anyone remember what that represents? So mu is the population mean. And then X bar was the sample mean. So you should know how to calculate those by hand or using the calculator. So does everyone remember how to do that? Plug all the numbers into some list, then you run one variable statistics on that list. So if you do that, it'll also tell you the couple of the measures of variation. So it will tell you the standard deviation. So you should know how to identify in the calculator what SX and sigma X are. So SX is the sample standard deviation. Sigma X is the population standard deviation. So if I say I give you this set of data, I will say whether it's from a population or a sample, and you should know how to pick these out of a calculator based on what it says. So if I put something underlined and in bold that says sample or population, I'm telling you where it's from. So that'll tell you which one of these to use. So the only thing that your calculator really won't tell you that I would ask is what? Or I guess there's two things it won't. It doesn't tell you the mode, does it? I don't think it does. So know how to find the mode and also the sample variance, the population variance. So just like SX was for a sample, SX squared is the sample variance, and sigma X squared is the population variance. So, and the next thing we talked about was the median. How did you find the median? That's the mean. That's the mean. The median is the number in the middle. Yeah, then you pick off each two at the end and then come to one in the middle if there's an odd number. And if there's an even number of values, you take the average of the two most middle. Or if you don't want to do that, you can use your calculator. So if there's a problem on there, like there is on one of the practice exams, it says, what does it say? What the heck did I put? There it is. Calculate the mean, median, mode, range, and variance for the sample data given. So it says sample. So you should use, if it asked for the variance and the standard deviation, you should use SX and SX squared. So then all you do is plug in those numbers to the calculator. It'll tell you the mean, the median, and the standard deviation, but it won't tell you the variance. So how do you do that? You literally just take the sample standard deviation your calculator gives you, take it to 3 decimal places and square it. That'll give you the variance. To find the mode, you would just look at the list and then see which value occurs the most often. If they all occur with the same frequency, then you would say there is no mode. That's simple. So, and then you all obviously know how to do the range. Okay. Using the calculator to find the 5-number summary. So that's just doing the one variable statistics on it. Already talked about that. So know how to determine outliers. So does everyone remember how to do that? So it involves the 5-number summary and the IQR. So you have the min, Q1, Q2, which is also the median, Q3, and the max. So from these numbers, if you're given these, you can find the IQR by Q3 minus Q1. That'll tell you the IQR. And then the lower cutoff for outliers is what? So lower cutoff is Q1 minus 1.5, times the IQR. So I'm putting that in parentheses because it's only 1.5 times IQR, not 1.5 times Q1. And then the upper cutoff is Q3 plus 1.5 times IQR. So what would be another way I could ask you to find those? What is one thing that we talked about in chapter 3 at the very end? There's another type of graph. Yeah, the box plot. So I could give you a box plot that looks something like this. So I could give you that. And this is the minimum here. This is Q1, this is Q2, this is Q3, this is the max. So if I gave you something like this, either these would be labeled or it's very obvious that you can see what it is. So then you could find the IQR. And you could find these two. So know how to do that. There is an example, number 21 on practice exam 2022. Is the upper cutoff Q3 plus, it's Q3 plus 1.5 times IQR. On one of the problems or one of the pictures on your chapter 4 notes, when I copied it in, it said Q3 minus, so I had to change it. So what else? So the last thing we talked about was chapter 4. This was the hardest one, and it will be the hardest one for this first exam. So some of your homework problems are quite difficult, right? They're kind of a pain. There's 28 of them. I don't know why it makes you do so many. 28 homework questions on chapter 4. I don't make them. The coordinator does it. So, and I can't take anything off there or I get in trouble. So they get very repetitive. And why is that? Yeah, so you know how to do it. So then some of them are quite tricky. Oh, there's one thing I didn't talk about yet. Did I? What chapter was this in? Yeah, I'm trying to figure out where this falls. Is it 3 or? Yeah, it's 3. So one thing we also talked about. So if you wanted to compare 2 different measures that had different units, what did you have to use? Called the coefficient of variation. So know how to find it and how to interpret it. Yeah, so all you do is the higher the coefficient of variation, the more variability. That's it. So if I gave you something on there, I would ask you to calculate the two coefficients of variation. And then based on those two calculations, you can tell me which one is more variable by which one has the higher coefficient of variation. There also is an example on the one of the practice exams that goes over that. So you should know how to determine, based on the wording I give you, which one is the mean and which one is the standard deviation. Obviously, if it says the standard deviation is this, please do not give that as the mean. I will laugh at you while I'm grading the exams. Oh, also, I don't know how long it'll take to grade the exams. There's too many people in this class. Way too many. Yeah, that happens. We'll be fine. I'll probably have it done by the weekend. I usually grade them pretty quick. There are two forms of the exam though, so that'll make it a little bit more difficult. I made that so you couldn't cheat. So, in the final chapter we talked about was probability. So, know what the sample space is and what the definition of it is. So the sample space is the set of all possible outcomes of a probability experiment. So the sample space is the set of all possible outcomes of a probability experiment. So then outcomes are obviously one of the possibilities you can get from a probability experiment. So if you toss a coin, it's head or tails. You roll a die, it's numbers 1 to 6. So you should also know how to determine the total number of possible outcomes. Say for instance, you're eating dinner or eating out at a restaurant. And you want to know the number of ways to have, let's see, an appetizer, entree, and dessert. Then how would you find the total number of ways? Yeah, you could do a tree or you can just multiply them. Yeah. So if you do a tree, it's going to lead to the same answer, but the tree is going to be quite long. So all you do is take the number of appetizers times the number of entrees times the number of desserts. So there's something similar to that on your practice exam too. It says there are 4 blood types, A, B, AB, and O. Blood also has Rh positive and Rh negative. Finally, a blood donor can be classified as either male or female. How many different ways can a donor have their blood labeled? So you have 4 different ways of having blood types. Then they also have 2 different ways of whatever Rh plus and Rh minus are. And then 2 ways of being classified as one is male, one is female. So the total number of ways would be 4 times 2 times 2, or 16. So the next thing that it says on here is the range of values that a probability can take on. What is that? So the lowest one it can take on is 0. And the highest is what? Yeah, 100% or 1. So that means the range of values that a probability can take on are 0 to 1, including 0 and 1. So the next thing, rules of complementary probability. You should guarantee know how to do this. It will show up in some way or shape on the exam. Complementary probability. So obviously you need to know what the complement is. So it's the set of all outcomes in the sample space that are not included in the event. E. So E is some event, it has some probability, and the complement of E is denoted E with a bar at the top. Another way they write it some places is E with a C and the exponent. So if I give you the probability that some event happens, you should be able to find the probability that the complement happens by taking what? Yeah, so the probability of the complement, probability of E complement is equal to 1 minus the probability of E. So you could also rearrange it to find the probability of E. It's just going to be the same thing, just swap these two. And then the final thing, the probability of E plus the probability of E complement is 1. Either something is going to happen or it's not. And the probability of each of them added together should give you 1. Everyone okay with that? Okay. So there was a question that I posed in class that will probably get most of you. What is the complement of at least 1? I remember one person was kind of confused, or a couple. So at least 1, the complement is 0. So say, for instance, there's a problem on your homework that deals with, I don't know if it's still on there. Is there one that has the number of veterans or something like that in the chapter 4 homework? So it says a certain percentage of the population is veterans. I want you to find the probability that all 5 of them are veterans and that at least 1. So if you want to find, I'll just explain it this way. So Y is 0, the complement of at least 1. So say you have 1, 2, 3, 4. Let's do 5 for make it easy. So the at least 1 means you could either have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. It could also not happen at all, and that would be the complement. So that's why. It's kind of confusing. So either something is going to happen here, not happen here, happen here, happen here, and happen here. So if all of these, or at least one of these is going to happen, the opposite of at least one of them happening is none of them happening. That's kind of
So at least one or more.
yes, one or more.
Complement would be 0.
Yes.
Gotcha.
Yeah, it's the opposite of it. So you should know how to determine that. So there's a question on the practice exam that you should know how to do. Which one is it? Did I put it on here? Okay, it's not on this one. It's on the other one. Where's that? Dang it, it's logging me out of Canvas. Wait, did it? So here we are. There's your exam. I haven't posted it yet, obviously. So that's what I think is where it is. Did I put it on here? I should have. What's up? Yeah, front and back. Okay, I know one of these. Yeah. So here it says find the probability that a person does not have type O blood using the complementary. This is just like what we did with the notes. So you should know how to do something like that. Also know how to read one of these. So that is what is known as a contingency table. You should know how to read it to determine the union of two events and also the conditional probability of an event. So the union. So if I want the probability that a person is male or a non-smoker, then I want to think of it first. Are these two events mutually exclusive or not? So can they occur at the same time? Yes, there's male and non-smokers. So then there's two addition rules we talked about. So one was if they're mutually exclusive, one's if they're not. Obviously, if they're not mutually exclusive, you use that rule. So then how would you find that probability? The probability of one happening plus the probability of the other happening minus the probability that both of them happen at the same time. So if we're looking at male and non-smoker, you look at what's the probability of them being a male. So you have to add up the total number of males. There's 25 out of 50 total. How many non-smokers are there? There's 10 out of the 50 total. Then I double counted those male non-smokers, so I need to subtract 10. Or there's 26 non-smokers total. I didn't add across the column. Does that make sense? So we'll say this: the probability of A or B. So for not mutually exclusive. Exclusive, that's what that means, is the probability of A plus the probability of B minus the probability of A and B. So if two events are mutually exclusive, they can't occur at the same time. So this probability of A and B is 0. So you can memorize this one right here, and it will give you the first addition rule as well. So know how to read that from a contingency table. So there also is a question on here that shows mathematically show if two events A and B are mutually exclusive. What is it asking you to do? So if two events A and B are mutually exclusive, then obviously this is the rule it will follow. All it's asking you to do is see if that condition is satisfied or not. If I tell you what this is, I tell you what this is, and I tell you what this is the probability of A or B that's going to be given actually equal to the addition of these two. If it is, they're mutually exclusive. If not, they're obviously not. What else? What else do I say? Okay, conditional probabilities. Does everyone remember how to do that? Using a contingency table again. So you should know how to interpret what it says. So what is the probability of passing exam 1 given you attend class? So then to find that, so this given part here is after this little bar, basically an absolute value thing. So the probability of passing the exam, so that would be this, so pass exam, given that you attend class. So by definition, this is equal to the probability that you pass the exam and you attend class divided by the probability that you attend class. So another way you could write it is the probability of A given B is equal to the probability of the intersection A and B divided by the probability of the given term, probability of B. So whenever we talked about this, I kind of used a tree to illustrate it. So using a contingency table, you can easily find what's the probability of A and B. So I give you two conditions and I say, find the conditional probability of this given this. You look at the probability of the intersection, and then you divide that by the probability of the given condition. So there is a tricky one on your practice exam. This is, I don't know if it's one of your homework questions or not. So it's number 19 on the practice exam. So I guess I can actually go over that since it's kind of tricky. Maybe. I won't tell you. I have your exam right in front of me. I actually have both of them. The question is, which one am I looking at? Or am I looking? Where in the world did I put it? Oh, it's right here. I'm stupid. There we go. That's what I'm. That happens. So where is it? Here we are. This one. So at a large pharmaceutical company, 62% of sales representatives are women. 44% of sales representatives that have a management position are women. 25% of sales representatives have a management position. Now calculate the following. Okay, so first thing you want to do is identify what in the world do these mean. So this says 62% of the sales representatives at this company are women. So the probability of being a woman at this company, so just women, is equal to 62% or 0.62. So the next part, what probability do you think that is? This one is tricky. Yeah. Oh, I'm sorry. There you go. So 44% of sales representatives that have a management position are women. that means that the probability of being a woman, given that you're a manager, is 44%. That's the tricky part. This last one is easy to interpret. The percentage of management positions. So the probability of a management position is just 25%. So the probability of manager is 25% or 0.25. So then the first part says, find the probability that a randomly selected sales representative has a management position and is a woman. What probability am I asking for? That's the probability of women given management. I want the probability that they are women and a manager. So I want the probability of the intersection. So we're given the conditional probability here. I know the probability of women given management is equal to the probability of the intersection, so women and management, divide by the probability of management. What part of this formula do I have and which part do I want? You have these two parts. You want this part. How do you do that? Take this probability and then multiply it by that. So that implies that the probability of women and management is equal to the probability of women given management times the probability of management. It gives you both of these probabilities. This probability is 0.44. This probability is 0.25. The multiplication of the two gives you 0.11. That's the answer. So if you're curious if the key to this thing is actually up, your practice exam, both of the keys are up if you want to look at them. So there is one tricky question on there. Well, I guess there's a couple. So the first one says the age of women who were, I'll just flip to the front since it's on here. So the age of women when they were first married is a continuous variable. Is that true or false? And why? Age is based on what? Age is based on time. And what is time? Continuous, so it's continuous. So what else? Is there anything in here? Okay, so let's look at number 5. If the relative frequency of a class is 0.16 or 16%, and the total amount of observations in the data set is 250, then there are 30 observations in that class. How would you determine if that's true or false? I tell you the number of observations in the class. I tell you the total frequency. You can find the relative frequency by taking the ratio of the two and seeing if that number or percentage actually matches what is there. So does 30 over 250 actually give you 0.16? No, it does not. I don't know actually what it gives you. Let's see. So that's 3 out of 25. So it's 0.12 or 12%. Oh, I didn't talk about this. You should know how to interpret this too. So percentile. If a person scores on exam what the heck? If a person's score on an exam corresponds to the 75th percentile, then that person obtained 75 correct answers out of the 100 possible questions. What is that? Anyone? You can guess. False is correct. So the percentile is the percentage of people less than or equal to the number you're interested in. So what else? Okay, let's look at one of these. So, except for rounding errors, frequency should add up to what sum? 1, 2, 100, or n? Remember, what is n? Yeah, the number of values or your sample size. So, the number of frequency should obviously add to that. The other three are just BS. So, please don't give me a BS answer. I put plenty of them on the exam. They're meant to trick you. So, this next one is a trick question. A statistic that represents the very center of the data set is the what? Median. It's 50th percentile. So, could the mean be in the middle? Yes, it could. Could the mode be in the middle? Yes, it could. Could the mid-range? Possibly. But no matter what, every single time the median will be in the middle because it is the 50th percentile. Oh, did I talk about this? No, I did not. So we will do it now. So I guess let's look at 10 and 11 real quick. The complement of guessing 5 incorrect answers on a true and false quiz is what? So it's saying, what's the opposite of getting everything wrong? Close. Yeah, getting at least one right. So getting at least one correct answer, so B. So if events A and B are independent with the probability of A being this and the probability of B being this, what is the probability of A and B? How would you find that? No. Close. No. Close. You're almost there. So there's add, subtract, multiply, and divide. So we've got subtract and divide are wrong. Add goes to mutually exclusive events, so obviously going to multiply. So I'll write it up here. Right? I'll just write it here. If two events A and B are independent, then the probability of A and B is equal to the probability of A times the probability of B. That's if they are independent. So I say they're independent here. I give you the probability of A and I give you the probability of B. To find the probability of the intersection, you just multiply the two. If you do that, you get what? The 0.31. Okay. Let's see, is there any other particular one I want you to know how to do? Okay, let's look at this one. Given a sample space with events A and B, such that the probability of A is this, the probability of B is this, the probability of A or B is this, mathematically show if events A and B are mutually exclusive. What is it asking for? Did I erase it? No, I did not. So if events A and B are mutually exclusive, the probability of the union or the probability of either of them happening is equal to the probability of one of them happening plus the other. So if I want to determine if these two events are mutually exclusive, I should just use this formula here and see if it satisfies that condition. So it says the probability of A is equal to 0.471. The probability of B is 0.123. So let's add those two up. What does it give you when you add them up? So if you add those two up, you get 0.594. So that means that this part on the right-hand side, the probability of A plus the probability of B is 0.594. And it tells me the probability of A or B, the left-hand side is 0.601. Obviously, those two are not equal. Therefore, A and B are not mutually exclusive. So that's all I'm going to go through on that one. I'll go to the other one real quick to see what it has. Share screen. We'll go here. Modules. Did everyone notice that I posted all the lectures? So some of them at the beginning of the semester I forgot to record. So I just pulled the lectures from a couple semesters ago. But the ones that actually have a date on them here that say lecture over this and the date, that is actually in the class recording. So I posted them on YouTube because it won't take up space in Canvas if I do that. If I do it in Canvas, then it takes up space and I can't upload anything else. So let's look at this one. This was the first semester I ever taught the class. This was their first exam. Okay, let's look at these. So if I divide the population of Oklahoma State undergraduates into those in Greek organizations and those not in Greek organizations, then I take surveys from both groups and want to compare the groups. What type of sample was drawn? Yes, stratified. You take the population of interest, the Oklahoma State undergraduates, you divide them into two groups based on if they're in a Greek organization or not. And then from each of those, you take a sample. I hate whenever that thing does that. So each person is asked about their education level, postgraduate, college graduate, some college, high school, or less. What type of variable is education? So I'm asking what measurement level does it fit into? Ordinal, yes. There's a natural order to them. The higher you go up in the list, the more education you have. Next one, you don't need, that's basically the same thing. So this one got a lot of people. So if a frequency table will have 5 classes and the minimum data value is 16, the maximum is 52, what is the smallest possible integer for the class width? So to find the class width, you take the range divided by the total number of classes. So what's the range in that case? 52 minus 16 is what? 36. 36 divided by 5 is what? 7.2. Remember, if n is a decimal, so if you get a decimal, round up. So the correct answer would be C. I got a lot of people that gave me B. So this one here, I tell you the standard deviation. I tell you the sample size. How do you find the variance? Yeah, all you do is square what? What number in there? Yeah, 1.96. Is the sample size involved anywhere in that part? No. So there is something in chapter 7 we will go over. It's called the standard error of the point estimate. In that case, it will incorporate that sample size. But for now, it does not. So here, I just give you this, so it's kind of easy to do. Okay, so this one is a combination question. So if I give you this, what should you do? Did I show you how to enter it in the calculator? I'm pretty sure I did. Okay, so all you would do is NCR. You need to tell it what N, the total number of object is. So there's 14 different objects. And how many combinations of 4 could I do from that? So it'd be 14, choose 4. So if you do that, it depends what calculator you have. If you do, so just enter in the N first. So it'd be 14. Then go to math, over to probability and NCR. And then once you have hit that, then you type the R value, which is, oh, it's 4, not 5. So if you do that, what do you get? You should get B 1001. Yes. What's up? Yeah, the math department. It's the 4th floor. Just walk straight in. So like whenever you go up, there's going to be mailboxes right in front of you. Go to the right. It's the building over, the math sciences building. So if you don't have one, I will bring a couple, but there's only like 4, and there's like a lot of you. So let me show you how to do this real quick, and then we'll get out of here. So here, so for instance, do 15. Oh, you can't see that. Do 15. That's the N number. Hit math, go over to probability, and go to NCR. Hit that. Then after that, you enter the number for RN. So if it was 4, enter in 4. And then enter, it'll tell you what it is. In that case, I entered the wrong thing and it was 14, choose 4, not 15. All right, so I guess we'll stop there. Best of luck. Don't forget, you're allowed 1 sheet of notes front and back, either handwritten or typed. Please be on time.